Hello, today I'm looking at M3 International A-Level January 17. This is question 2 and I can see that this is testing me on variable forces, variable acceleration. So here I have a particle of mass 0.6 is moving along the positive x-axis in the positive direction. The only force acting on P acts in the direction of x, increasing, and has magnitude of this, where t is the time and P after P leaves the origin. When time is 0, the particle is at rest at 0. Find an expression in terms of t for the velocity of P at time t seconds, and this is worth 2 marks. So this is the force, so I can use the equation with force in, that the resultant force is the mass times the acceleration. So I have resultant force is equal to the mass, and 0.6 is 3/5, multiplied by the acceleration. Now for the acceleration, I can use dv by dt, or I could use v dv by dx. And in this case, because they gave me the force in terms of t, I'm going to use dv by dt. Okay, so now I can separate and integrate in order to end up with an expression of v in terms of t. So let's get this 3/5 out of the way. So I'll multiply both sides by 5/3. And so on the right hand side I end up with the integral of 1 dv. So integrating the right hand side I end up with v. Integrating the left hand side I have 5/3 3t squared divided by 2 plus t over 2 plus a constant. And now I need some initial conditions in order to work out this constant. Now they told me when t is 0, P is at rest, so that means that V is 0. So when I pop T is 0 into here and V is 0 there, then I end up with C is 0. So therefore V is equal to 5/3 multiplied by, actually I can multiply that out. So the 3's here would cancel and you'll end up with 5/2 t squared plus 5t over 6 multiplying the 5/3 with the half. And C was 0, so that is it. So that is for the first 2 marks. Then it says the particle passes through point A with this speed. Find the distance from O to A. So if I put that V into here, then I could find out the value of T at that point. But really I want the relationship with the distance and time. So in that case I could rewrite V as dx by dt and then separate and integrate again. Okay, so for part B, first of all I shall pop in this value of 10/3. So I get that 10/3 is equal to 5/2 t squared plus 5t over 6, and I'm trying to work out at what value of t does this work. So I can see I've got a quadratic equation. So if I multiply everything by 6, that will go there, I'll be left with a 3, and here I'll be left with a 2, and then subtracting 20 I end up with 0 is 15t squared plus 5t minus 20, and I can divide everything by 5. I should have divided it by 5 there really, but anyway. Okay, so I end up with 3t squared plus t minus 4. Okay, so in order to try to solve this equation, then I can hopefully factorize. Let's try 3t and t. So there aren't too many different possibilities to try. So I think it would be a 4 there and a 1 there, and I need the 4 to be positive and this to be negative. Okay, so the only value at which the speed is 10 over 3. I can't have t as negative, so therefore t is 1 at point A. Okay, so now that I found that out, then I can rewrite v as dx by dt. So I get that dx by dt is equal to this thing. And now I can separate and integrate, so I will have the integral of dx equals the integral of 5 over 2t squared plus 5t over 6 integrated with respect to t, and doing that integral, then on the left hand side I get x, and on the right hand side I get 5 over 2 t cubed divided by 3, so this 2 will become a 2 times 3. Sorry, never write a number on top of another number. Okay, plus 5t squared and then divided by 2, so the bottom will become 12. I just integrated, so I need to write plus c. And now I need to pop in some initial conditions. Well, the initial conditions come from here. They said when t is 0, p is at rest at O. So in other words, when t is 0, x is 0. So when t is 0, x is 0. So if that disappears and that disappears and that disappears, I get that c is 0. So therefore x will be 5 over 6 t cubed plus 5 over 12 t squared. And now I can pop in this value of t that I found into this expression to find the distance OA. So when t is 1, I end up with x is 5 over 6 times 1 cubed plus 5 over 12 times 1 squared. And if I just double the top and the bottom of this one, then I end up with 15 over 12, which will simplify to dividing by 3. So I get 5 over 4 meters. So in other words, 1.25 meters exactly. Okay, so that part of the question is worth 5 marks. I hope you found this solution helpful. Good luck with your studies.